question from 2019-2020. Question 5 is says define stress, strain, your elastic modulus. That's not a problem. The B part says a spring extends elastically by 10 cm. When a force of 20 Newton is applied to it, full stop, what force would be needed to extend the spring by what? 6.5 centimeters. As usual, the case that solution lists out given parameters. What am I given there? The first thing that they said, a spring extends elastically. So the first you're given there is extension. Perhaps we call this extension. This is how you write an example. Extension E is equal to. Some of you have seen your work. We just write solution E is equal to this. No, just say E is equal. What's E? When you're saying E, define it. Don't assume you know. If that no, they would have been asking you to come and define it. So E is equal to 10 cm. So define it, comma, write symbol equal to this. Next up, part 2, they said when a force of 20 Newton, so this one I'm giving here is force, that's F equal to 20 Newton is applied to it. What force would be needed to extend the spring by 6.5? Number 3, I'm given another extension. Now, here's the concept. Look at this. Here's the concept. In my question here, I have how many extensions there? 2 extensions. So perhaps, let me call this extension 1. And this extension was caused by this force. I'll call this force 1. The question says, what force will be needed? That means I think what there is second force. So call this extension 2. This was 6.5 cm. I'm about to find what force. So extension force 2 is unknown. First steps here, first things first, please convert. Convert E1, that's extension 1 to meters. Becomes 10 all over 100. That gives you what there? 0.1 meters. Convert this one here. So E2 is equal to 6.5. Divide this by 100. That gives you 0.65 meters. So first of all, divide them, express them in meters. 0.065. Sorry. This will give you 0.065 meters. Right, so I have this. So what's next here? This equation, it said what force? I'm looking for F2. F2 is unknown. What force will be required to extend it by this? So F2 is the force required to cause this extension. Here's a problem of what's it called? Hooke's law. From Hooke's law, I have that what's what? So recall that from Hooke's law, F is equal to KE. What we said K is what? Spring constant, or what? The stiffness of spring. Let's use for F1, for force 1, for F1, you have that F1 is equal to K times E1. Now look at this, say K1. It's called force constant or spring constant. That means it's constant. There's no K1, there's no K2. So while the value of F and E can change, K does not change, it's constant. From here, let's get K. Divide them by E1, divide them by E1. Obviously, these two cancels out. So I'm having K is equal to F1 over E1. Put in values. F1 is this, becomes 20, of course, in Newton, all over E1 is 0.1 to 0.1 in meter. Please give me value. 200 what? Units? Sorry? This over this. Newton, this is what? As before, is per, not back. Not the same thing. Newton per meter. This. So let's find the force. Hence, you have that F2 is equal to KE2. From here, you can get F2, right? So F2 is equal to K is 200 times E2. What's E2 there? 0.065. Please multiply this to what's F2? Sorry? 13. Units? Newton. So F2 is 13 Newton. So the force required to extend that same spring by this amount is 13 Newton. That's how you solve this question. So the lecturer says a wheel of 40 cm radius rotates on a stationary axle, full stop. It is sped up from rest to a speed of 900 rpm. What's rpm? Sorry? Radian revolution. What's rpm? Revolution per minute, not radian. 900 revolution per minute in a time of 20 seconds, full stop. What is the constant angular acceleration in brackets in rad per second squared of the wheel and the tangential acceleration of a point on its wheel? Now, in this question, you have to find two things. Both acceleration. You have to find both the angular acceleration and what you get there? Linear acceleration. Both the tangential also mean what there? Linear. Right. You have to find both angular acceleration and linear acceleration. Solution please. Help me list out given parameters. What are you given there? Number 1, I'm given radius R. How many there? 40 cm. Am I converting? Yes. Please convert this. From here, R is equal to 40 divided by 100. It gives you what there? 0.4 meters. What next? Then it said sped up at a speed. Number 2, I'm given speed. Speed of what there? Speed. What is for speed? What is for speed? What's your representation? Huh? For speed, what's your representation? When you say speed in RPM, what does it mean? It's an angular speed. Get it right. Angular speed or angular velocity is what there? Omega. Please careful though. Omega, how many there? 900 RPM. So RPM means revolution per minute. Of course, if I have revolution per minute, convert the word there, rad per second. So how do you do that? I gave you a relationship. I said what's the relationship there? 1 rev is equal to what there? 2 pi rad. Alright. So it means that this is equal to 900. Now listen. Here's my simplest way of explaining conversion. 900, I said shift out the number from the SI unit. It becomes 900 rev per minute is equal to, this means 1 and 1. 1 over 1 gives you 1 times 900 gives you 900, same thing. This now becomes 900 times 1 rev, as you can see here, is 2 pi rad. So 2 pi rad. This now becomes the 1 rev. 2 pi rad. In 1 minute, convert to seconds. How many seconds in 1 minute? 60. Becomes 60 seconds. This conversion is easy. Work this out. This is now equal to, from here, this can cancel this. 2 here 1, 2 here 3, 3 here 1, 3 here 30. That gives you 30 pi rad. 30 pi rad per second. 30 pi rand per second. Please punch 30 pi. What do you get? 30 pi. What do you get? 94.26 approximately in what? Rand per second. 25 rand per second. Alright, so we have this. What's this again there? They said find the what? Next up is time. See how many? 20 seconds. So number one, we have to find angular acceleration. Angular acceleration. We had two definitions of angular acceleration. By the way, this one is alpha. Angular acceleration is alpha. We said, recall that alpha is equal to what? Omega over t. Change in angular velocity or angular speed. So that's equal to, this value is what? This 94.25 all over t. What's t? 20. Alright, so this is now rad per second all over second. Please punch this. What do you get? 4.71 in what? Rad per second square. It says you find this in rad per second square. Also, it's 4.71 rad per second square. The next one says you find tangential acceleration. Tangential acceleration, which is a normal acceleration, which is A. Recall our relationship. We said angular acceleration is equal to what there? Linear acceleration over what there? Radius. Divided by 1. This times this. A times 1 gives you A is equal to this times this, and R. In big value, what's this? 4.71 times what's R? 0.4. So it means tangential or linear acceleration is equal to what there? 1.88 units meters per second square. This is how you solve this question. See how simple your test in your exam is. Next one says if you move a crate across a frictionless floor by a rope that is inclined 30 degrees to the horizontal with a tension of 50 Newton, how much work have you done after moving the crate through a distance of 1000 cm? So look at this. Solution. For questions of this nature, I would advise you draw a diagram. Draw a diagram, it's not a big deal. I have, so I'll call this my rough surface. Call this the rough surface. This one here. Just sketching it for a crate. Because crate is usually rectangular. So just call this a crate. So here's your crate. Now look at this. Look at this. We said the crate is tied a string and is inclined at an angle this way here. And look at this. For this to be inclined at an angle, there must be a base for it. We are assuming this to be the base or the that tube of reference, which should be parallel to this angle here. What's the angle there? 30 degrees. So I have this. They said, what's the tension in the string? How many? 15 newton. So here is 50 newton. They asked, what work have you done in moving this to a distance of about 1000 cm? So let's say from here to here is 1000 cm. So now start asking, do you have the whole draw diagram? Of course you don't have to. Of course you don't have to. But then again, to separate your work from others, draw diagram. Remember those days when the one used to draw diagram? Somebody said you will never see to make in the exam. And I asked why. He said I used to do too many unnecessary things. I'm not kidding, he told me some stuff. Right? But the idea is always try to, in any case you have, try to separate your work from others. Most persons will not do this. But when you do something like this now, it just separates your work from others. It doesn't like this guy knows what he's doing. It's just like a concept there. But that's by the way. So here's one concept. Next up, you have to find work done. In physics, work is said to be done when a force moves a body through a distance in the direction of that force. That's work done. Now, mathematically, work is equal to what there? Force times distance. What is the problem for this? I have a force there, which is 50. I have distance 1000 cm. By the way, please, distance. So given distance, let's say s is equal to 1000 cm. Please convert this to meters. Distance equal to 1000 over how many? Over 100. That gives you 10 meters. So I have 10 meters for this in here. I have a force. The force here is 20 newton, of course. The force is inclined, so I can't use that force. Whatever a force, look up. Whenever you have a force inclined at an angle F to the horizontal theta, that force usually has two components. The vertical component, the horizontal component. This one is called horizontal component, Fx. Here is called vertical component, Fy. We know that Fx is equal to what there? F cos theta, and Fy is equal to what there? This is because the angle of inclination is to horizontal. If this angle was to the vertical, Fx equals what there? F sin theta. So careful. Alright. So in this case now they said I'm moving this plate. That means this force here has two components. Either this one here, call this the Fx component of it, or this one here, call this the Fy component. Question now be which of these two forces will be responsible for moving this plate? Obviously, if I consider Fy, if I drag the plate this way, Fy, instead of moving the plate horizontally, I'll be lifting it up. True of us? True. So Fy will not move this man this way. Instead, it will lift up the plate. So that means the first component responsible for moving this plate this way is what there? Fx. So hence, I will take the horizontal component of the force. From here, we have that horizontal component of force Fx. So Fx is equal to F cos theta. F is 50, the force. So 50 cos angle of inclination 30. This is about 25, right? Sorry, how many you guys here? So Fx is equal to what? Talk to me now, what do you guys say? 43.30 Newton. So therefore, work done, which is equal to force times distance. That's equal to force. Force is 43.30 times distance is 10. So multiply this gives you what there? 433. Hold on, is it 433 or 430? Good. That's 433, Abi. Don't mean to say 4330 to be wrong. So 43.0 perhaps. What is going to be what? Joule. This is equal to 433 joule. So this is the amount of work done in moving the crate by 1000 cm. That's how you solve this question. Alright, let's look at the last question from there. It says, find the weight of a body on Earth whose mass is 5 times 10 to the power 5 grams if this body were in space at a distance of 12 kilometers from another body of mass 1.5 times 10 to the power 5 grams. What is the magnitude of the gravitational force of attraction between both bodies? So this one links up to what there? Newton's law of what? Universal gravitation. Now, head on. Solution. List out given parameters. What are you given there? Number 1. Mass M1, Abi. How many there? Don't forget, mass should be equal there. Kilogram. So convert gram to kilogram. Kilogram is 10 to the power 3. So this will now, that means M1 will be equal to, express this in terms of 10 to the power 3. That gives you 5 times 10 to the power 2 times 10 to the power 3 before the gram. From the concept of indices, if 2 bases are multiplying, add up the power. 2 plus 3 gives you this 5. So this 10 to the power 3 is what gives you what there? Kilo. Alright, so this one here is what gives you kilogram. That means M1 is now equal to 5 times 10 to the power 2, these 2, kilogram. That's equal to 500 kilogram. So M1 is 500 kilogram. So what next there? Next we said, if this body were in space at a distance, number 2, distance. When it comes to the concept of Newton's law of universal gravitation, distance is what here? R, Abi? Right. R is how many here? 12 what? Kilometers. Convert this to meters. R is equal to 12. Kilo, we said, is this 10 to the power, times 10 to the power 3 meters. Depends on what to simplify. This gives you 12, 1, 2, 3 meters. You have this as your R value. Next up, it says from another body of mass. So you have your second mass, but 3 mass M2 is about 1.5 times 10 to the power 5 grams. Convert to kilogram. M2 is equal to 1.5 times, same concept here, 10 to the power 2 times 10 to the power 3 gram. And then you'll be asking, how come we've done this before? Why is it repeating again? To make the stuff plenty, Abi? So it's equal to 1.5 times 10 to the power 2. This one is kilo, it gives you kilogram. So it's equal to 1.5 times. I really answer here, but right now is what there? 100 kilograms. That's M2. So it means that M2 is equal to what there? So M2 is equal to 150 kilograms. Alright, so recall from Newton's law of universal gravitation that the force of attraction between two masses is directly proportional to the product of the masses and inversely proportional to what? The square of their distance apart. And after getting your mathematical expression, G is equal to X equal to what there? G M1 M2 over R squared. So M is equal to, what's the value of G? Constant 6.67 times 2 by what there? Minus 11. Alright, so this gives you 6.67 times 10 to the power minus 11 is a constant times M1. M1 is what? That one there. 5 times 10 to the power 5 into M2. M2 is, sorry. M1 is this, sorry. So M1, what I have there is 500. M2 is this 150 all over R squared. Alright. So all over this one here. 1, 2, 1, 2, 3 square. Please give me numerator only. What do you get? 5.0025. Is that one? 10 to the power minus what? 6. All over. This stuff is large. So you will give me this answer in standard form. Right, it's a large value. Give me standard form. What do you get there? 1.44 times 10 to the power 8. So perhaps you could use this value instead. Because this stuff is large. When you square it becomes too large. So perhaps you could just use this one instead and square. Same thing though. So you have that F is equal to, please divide these two. Now, here's how to punch this. Open bracket. Type this one into it. Close the bracket. Divided by open bracket. Type this one in, close bracket, equal to, what do you get? What do you get? 3.47. Think about what? Minus 14 Newton. Alright, express this in terms of the prefix. F will be equal to, the closest to this is what? 12 minus 12, which is pico. That's pico. Gives you 3.47 times 10 to the power minus 2 times 10 to the power minus 12 Newton. Minus 2 minus 12 which is minus 14. So I have that F is equal to 3.47 times 10 to the power minus 2 times this one. 10 to the power 12 is called pico. That's small p and then m. Alright, so F will be equal to, if you multiply this, to give you what F? 0.0, multiply this. Here. If you multiply this by this, give you this one here, times this one here, pico Newton. So this is the force of attraction between them. So that's how you solve this question.